Okay, good morning, good afternoon, and good evening. And then anyhow, that I'm not gonna say night yet, but this is the continuation of that ongoing calculus series of the BSA, Busadi Statistics and Business Academy. Okay, let's go ahead and look at that. What kind of a calculus problem we're gonna look into today? Okay, let's look at this one. Okay, look at this integral. I'm gonna get into this integral. Let's say this one 1 over root x plus 1 dx. See, this is today's integral. How could we gonna get this done? In a situation like this, we're gonna getting into that, as I mentioned in the previous cases, you're gonna looking into whether this guy's derivative gonna be on the top. For sure, it's not being there. You can take one of these, and then for sure, here you have to go for some kind of a substitution. The substitution should be what? Either this guy, the inside part, or the whole thing, or whatever. That definitely it's not gonna be u. It's not gonna be x for sure. You know that. If you take u equals x, there's nothing gonna change over here. But you have to figure out whether you're gonna take square root x or square root x plus 1. Let's say let u equals square root x plus 1. See? X plus 1. Then take the differential on both sides. When you take the derivative on this one, the same thing I'm going to write this way, x plus 1 to the half. See? Same thing being written in this one. This is called radical notation. See? This one called the rational exponent notation. I'm talking about this one. I'm talking about this guy. Okay? Same thing. If you take the derivative, half x plus 1 half minus 1, and you go and do the derivative of the inside from the chain rule. Chain rule. Use the chain rule, and you get 1 plus 0. Therefore, you can have dx, and you're going to have half x plus 1 minus half dx. That same thing I'm going to bring to the numerator. See, x plus 1 half dx, and make it positive now. See? Make it positive. I'm going to make this one positive. Okay? Like that. Positive, and I don't like that notation. Therefore I'm gonna say du equals nothing but 1 half square root x plus 1 dx, and I'm going to go back here. Okay. Here. See, I have this u. See, u equals x plus 1. You can remember. Okay. Therefore, we can say du is nothing but 1 over 2. See, this whole thing is u dx. Okay, dx. Then dx is nothing but 2u du. See? See? So we change the operator. So that means this can be easily replaced by this guy. This guy can be easily replaced by u. How about this guy? How do you get this one? From this one, I'm going to square both sides. Then you get this one, you get x plus 1 square root, I'm gonna square, then you get x plus 1. See? You're gonna get x plus 1. See? Then I need the x by itself. So this is gonna be u squared minus 1. U squared minus 1. Then I need the square root. So that means u squared minus 1 is root x. See? Positive root x. See? So root x can be replaced by this term. So let's replace. See? Integral 1 root x I replace by u squared minus 1. This one I replace by u. I'm sorry, u. See? Root x see? I square this one, then I got this one, then I got the one to the other side. In this order to have the root x, I did like this, then I change the root x in this one, this part being replaced by this part being replaced by root u squared minus 1. This part being replaced by u. This part being replaced by 2u du. That's the idea. You see? That's what I'm doing here. See? And 2u du. Then u get cancelled off. See? U get cancelled off. Then you are left over with see, 2 I can pull out from the integral, 1 over u squared minus 1 is 1 dv. You get cancelled off, you get that one. Then u squared minus 1, 1 minus u squared. 1 minus u squared, you know how you tackle, no? 1 minus u squared, can you remember? 1 minus u squared, you can say if you have 1 minus u squared, here you have what? U squared minus 1. U squared minus 1. 1 minus u squared, it's sine inverse. This is not sine inverse, but we know trigonometric substitutions. What are those? If you have something like this, let's say you have a u squared minus a squared, you can say u can be replaced by u means a secant theta. If you have a squared minus u squared, you can replace u by a sine theta. That means the square root of that. If you have something like this, a squared plus u squared, u equals a tan theta. You can remember trigonometric substitutions. This power can be anything, okay? I just put the radical for the sake of putting something, but this structure, if it is in this format means this structure, you can, u can be replaced by a secant theta. A squared minus u squared, you can use this one. So here, then we can go to another substitution. Let u equals nothing but a is u squared minus a squared is 1. You don't have to worry about 1. 1 times secant theta. See? Great. So then take the derivative. This one going to be secant theta tan theta d theta. So So that means if you have a du can be replaced by, see, this whole thing. See, that means here, this can be replaced by secant theta, tan theta, d theta. This u can be replaced by nothing but secant theta. See, that's replaced. It's a second substitution. Okay? Let's replace. Erase this one too. And let's replace it. Okay. 2 integral 1 square root, okay, u squared means secant squared theta minus 1 du is nothing but secant theta tan theta d theta. Secant square theta, we know that this is nothing but what? 1 plus tan square theta is secant square theta. We know that. And therefore, I'm going to use therefore this one, okay? These 3 dots at the vertices of equal triangle. Therefore, secant square theta minus 1 is nothing but tan square theta. So this can be easily replaced by 1 over square root tan square theta secant theta tan theta d theta. That's my I. Okay, this is my I. Therefore, I is what? 1 over, you get tan theta. On the top you have secant theta, tan theta, d theta. Tan theta get cancelled. You are left over with 2 secant theta, d theta. We know that the integral of secant theta is nothing but what? Nothing but ln nothing but 2 ln secant theta plus tan theta plus c. Plus c. Now we didn't start with theta. We started with what? We started with x, and halfway through we had u. Then we have to go back. Systematically you have to remove theta and write that one in terms of u. We know that. We know that u is nothing but secant theta. Let's set this into a right triangle. Secant theta means, that means hypotenuse over adjacent. You know that in a right triangle. So if this is my theta, secant theta means hypotenuse. This is u over 1, see? This is u over 1. Hypotenuse adjacent. If that's the case, this should be nothing but u squared minus 1. From that one, let's write the secant theta. Secant theta is already u, plus tan theta is u squared minus 1, u squared minus 1 over 1 square root over 1 plus c. This is 2 ln u plus square root u squared minus 1 plus c. We got this one from the Pythagoras theorem. We know that one, okay? We know this one, how we got this one. Okay, at this stage. See? It's from the Pythagoras theorem. See? This squared minus this squared and square root. Now we're not done yet. See, still we have u. We don't have x. But we know that, we also know that u is nothing but root x plus 1. Okay? So let's replace u now. Therefore, I 2 ln u means root x plus 1 plus square root u squared means x plus 1 whole thing squared minus 1 plus 3. So therefore I is 2 ln square root x plus 1 plus within the square root you're going to have x plus 1 minus 1 plus c. Plus 1 minus 1 get cancelled out. Ln x plus 1 plus root x plus c, root x plus c. See? See? If you want to pull out the negative, look at another way of writing this now. Negative ln, if that's the case, I'm going to use the conjugate of inside, conjugate of the argument. This is called the argument. Argument of natural log. See? Natural log. This ln, okay? Natural log, ln. Natural log. See? You use its. Let's see. This is called conjugate of argument of ln. Argument of ln. Okay? Argument of ln. Okay, then this is the answer. So either you can write in this form or this form. So we got the answer. Let's see this kind of a question again, and then I'm going to see you guys in another question like this in another video. Thank you very much. You guys have a great day, wonderful day. Thank you. Bye-bye.